Right now, as you watch this video, there is a planet out there, roughly 1,400 light years from where you are sitting, that is being slowly eaten alive by its own star. Not a metaphor. Not science fiction. It is losing 6 billion tons of its atmosphere every single second. And in about 3 million years, it will be completely gone. Swallowed. Erased from existence. And that is not even the most extreme planet on this list. Today, we are going to walk through 7 worlds that will completely change the way you think about what a planet actually is. Some of these are so hot that iron vaporizes in their sky. One orbits its star backwards, because millions of years ago, something hit it so hard it flipped its entire trajectory. And the last one on this list is so unimaginably large that if you placed it at the center of our solar system, it would swallow Mercury, Venus, Earth, and Mars completely. These are not fictional planets. Every single one of them has been confirmed by NASA and leading astronomers. Let's get into it. Planet 1, WASP-12b, the planet being eaten alive. Let's start with the one I mentioned in the opening, because honestly, nothing better sets the tone for this list. WASP-12b is a gas giant located about 1,400 light-years away in the constellation Auriga. It was first discovered in 2008 by the Wide-Angle Search for Planets program, a UK-funded telescope survey that monitors millions of stars looking for tiny dips in starlight caused by a planet passing in front. When scientists first measured this planet, they were shocked. Not just because of its size, nearly twice the radius of Jupiter, but because of what it was doing. WASP-12b orbits its host star at a distance of just 2.1 million kilometers. For context, Mercury, our closest planet to the Sun, orbits at 58 million kilometers. WASP-12b is more than 27 times closer to its star than Mercury is to ours. At that distance, it completes one full orbit in just 1.1 days. 1 year on this planet lasts about 26 hours. The consequence of being that close is catastrophic. The star's gravity pulls so strongly on the side of the planet nearest to it that it has actually deformed WASP-12b's shape. It is no longer a sphere. Hubble Space Telescope observations confirmed it has been stretched into the shape of an egg, a football, due to what scientists call tidal forces. But the real horror is the mass loss. The star is so close that it is physically pulling the planet's outer atmosphere off and pulling it into a glowing disk of gas around the star itself. Scientists have measured this. WASP-12b is losing approximately 6 billion tons of material every single second. That number is almost impossible to picture. 6 billion tons per second. A 2024 study from the Asiago Observatory, which combined 12 years of observational data, revised the original estimate and concluded WASP-12b will be fully consumed in about 3 million years, earlier than previously thought. 3 million years sounds like a long time. In cosmic terms, it is nothing. Our universe is 13.8 billion years old. In the timeline of the universe, WASP-12b is already in its final moments. Planet 2, KELT-9b, hotter than most stars. If WASP-12b is a planet being destroyed by gravity, KELT-9b is a planet being destroyed by heat. Located 670 light-years from Earth in the constellation Cygnus, KELT-9b holds a distinction that most people find hard to believe the first time they hear it. It is hotter than the majority of stars in our galaxy. Its dayside surface temperature reaches 4,600 Kelvin, that is roughly 4,300 degrees Celsius, or about 7,800 degrees Fahrenheit. For comparison, our Sun's surface sits at around 5,500 degrees Celsius. KLT9b's dayside is only about 1,000 degrees cooler than the Sun. And this is a planet, not a star. A planet. The reason for this extreme heat is its host star, KLT9, a massive blue A-type star that is 2.4 times more massive than our Sun and twice as hot. KLT9b orbits this stellar furnace every 1.5 days at a distance of only 0.035 Australian dollars, roughly 30 times closer to its star than Mercury is to ours. At those temperatures, chemistry, as we understand it, breaks down completely. Water cannot form. Carbon dioxide cannot form. Methane cannot form. The heat is so extreme that even molecules of hydrogen gas, the most basic molecule in the universe, are being torn apart into individual atoms on the dayside of the planet. Scientists from the University of Chicago, using data from NASA's Spitzer Space Telescope, found direct evidence of this molecular destruction in 2018. The atoms are then swept by ferocious winds over to the slightly cooler night side, where they briefly reform into molecules, only to be blasted back to the dayside and torn apart again. It is an endless cycle of molecular destruction and reformation, happening on a planetary scale, every single day. Meanwhile, all of this energy is inflating KLT9b's atmosphere enormously. Despite being nearly 3 times the mass of Jupiter, it is only half as dense, because the atmosphere has ballooned outward under the relentless radiation. The long-term future is grim. Scientists estimate the planet could be fully evaporated, or stripped down to a bare rocky core, within a few 100 million years. Planet 3, WASP-17b, the planet that orbits backwards. Here is something that should be impossible. According to everything we understand about how solar systems form, a planet and its host star should always rotate in the same direction. They form from the same spinning disk of gas and dust. Physics demands they move together. WASP-17b broke that rule entirely. Discovered in 2009 and located 1,300 light-years away in the constellation Scorpius, WASP-17b was the first planet ever found in a confirmed retrograde orbit, meaning it travels around its star in the exact opposite direction of the star's own rotation. It is driving the wrong way down a one-way street. How does that happen? The leading theory is violent. Billions of years ago, WASP-17b was likely involved in a near-catastrophic gravitational encounter with another large planet, or possibly a passing star. The gravitational slingshot from that collision was powerful enough to flip the entire trajectory of a planet nearly twice the size of Jupiter. The energy from that event was so massive it left permanent scars in the form of the tidal heating that has been puffing up the planet ever since. In terms of pure size, WASP-17b is remarkable. Its radius is approximately twice that of Jupiter, yet it contains less than half of Jupiter's mass, making it one of the least dense planets ever discovered. Its density is so low it has been compared to styrofoam. The Hubble Space Telescope also confirmed the presence of water vapor in its atmosphere in 2013, making it one of the first exoplanets to have its atmosphere studied in detail. Planet 4, HAT-P67b, the planet on the edge of existence. Every physical object has a limit. Push it too far, and it falls apart. HAT-P67b appears to be sitting right at that edge. Located 1,200 light-years away in the constellation Hercules, HAT-P67b holds the current record for the largest confirmed exoplanet radius ever measured, at 2.14 times the radius of Jupiter. It was first discovered by the Hungarian-made automated telescope network and confirmed with refined measurements from test data analysis in 2025. Despite its enormous size, its mass is only about half that of Jupiter. The math on that should not work. A planet twice Jupiter's width, but only half its mass should not hold together, and according to scientists, it barely does. HAT P67b orbits an F-type star that is significantly hotter and larger than our Sun, completing one orbit in just 4.8 days at a distance of only 10 million kilometers. The radiation it receives is overwhelming. That stellar energy penetrates deep into the planet's atmosphere, superheating the gases and forcing them to expand outward. But because the planet's core mass is so low, its gravitational anchor is weak. Scientists describe it as a planet sitting dangerously close to the point where its own gravity can no longer contain its expansion. If it received even slightly more heat, or if its mass were marginally lower, the planet would likely cross a threshold where gravity simply gives up, and the entire planet would unspool into space, becoming a wandering cloud of hot gas rather than a coherent world. Watching HAT P67b is like watching a balloon inflated to the very second before it pops. Planet 5. PDS-70b, the planet still being born. Everything on this list so far has been a planet in some stage of dying. This one is different. PDS-70b is a planet we are watching form in real time. Located 370 light-years away in the constellation Centaurus, the PDS-70 system is only about 5 million years old. Our own solar system is 4.6 billion years old. On the scale of cosmic time, this system was born last Thursday. Inside this young system, PDS-70b is a protoplanet, a planet still actively accumulating mass from the surrounding disk of gas and dust. Its estimated radius ranges from 2 to 3 times that of Jupiter, but those numbers are uncertain because the planet has not finished growing yet. As the planet's gravity pulls in material, that matter crashes into its surface at enormous speeds, generating massive amounts of heat. This is why PDS-70b glows red hot. It is not reflecting starlight. It is producing its own light from the violence of its own creation. What makes this even more remarkable is that PDS-70b is already building its own moon system. Astronomers have detected a circumplanetary disk, a ring of gas and debris orbiting directly around PDS-70b, that contains enough material to form several Earth-sized moons. We are literally watching the architecture of a small solar system being assembled in real time. Planet 6, GQ Loopy b, planet or failed star? 500 light-years away, in the constellation Lupus orbits an object that astronomers genuinely cannot agree on how to classify. GQ Loopy b has a radius estimated at around 3 times that of Jupiter. Its mass estimates vary so wildly, anywhere from 1 Jupiter mass to over 30 times Jupiter's mass depending on the study and the age assumed for the system, that scientists cannot definitively place it in either the planet or brown dwarf category. A brown dwarf is essentially a failed star, an object massive enough to partially fuse hydrogen, but not massive enough to sustain the nuclear reactions that make a true star. The dividing line is roughly 13 times Jupiter's mass. GQ Loopy b sits right in that uncertain territory. What is truly strange is its orbital position. It sits approximately 100 astronomical units from its host star, more than 3 times the distance between our Sun and Neptune. At that distance, there is simply not enough raw material in the disk of a young star for a planet to form the way planets normally do, by slowly accumulating bits of rock and ice. The conclusion most astronomers favor is that GQ Loopy b formed the same way stars form, through the direct gravitational collapse of a cloud of gas. Which means it is not really a planet at all. It is a failed companion star that simply ran out of mass before it could ignite. Planet 7, HD 100546b, the largest known planet. If every planet on this list has been extreme, then HD 100546b is in a category entirely its own. located 359 light-years from Earth, HD 100546, beholds the most staggering size measurement of any confirmed planetary body. Its radius has been estimated at up to 6.9 times that of Jupiter. If that measurement holds up under further observation, it is not just the largest known planet. It is so large that placing it at the center of our solar system instead of the Sun, it would engulf the orbits of Mercury, Venus, Earth, and Mars. Like Pedia 70b, HD 100546b is still in the process of forming. It is embedded inside a massive protoplanetary disk surrounding its host star, a brilliant B-type star far more massive and luminous than our Sun. The planet orbits at 53 astronomical units, farther out than Pluto's orbit around our Sun, and is still actively sweeping up gas and dust from the disk. Its mass is deeply uncertain. Estimates range from a few Jupiter masses to potentially over 20, which puts it right on the boundary between a supermassive planet and a brown dwarf. Whether HD 100546b ever fully earns the title of planet depends on what it ultimately becomes as it finishes forming. What we know right now is this: it is the largest thing we have ever found that could be called a planet. And we found it in a star system only 359 light-years away, practically next door in galactic terms, which suggests that objects like this are likely far more common across the universe than we previously imagined. 7 planets. 7 worlds that challenge everything we thought we knew about what a planet can be. A world being eaten alive. A world hotter than a star. A world orbiting backwards. A world on the edge of falling apart. A world still being born. A world that might be a failed star. And a world so impossibly large it makes our entire inner solar system look like nothing. Space is not empty. It is filled with things we are only beginning to understand. If you made it to the end of this video, drop a comment below and tell me which of these 7 planets you found most terrifying. I read every single one. Subscribe if you want more videos like this, because we are just getting started.